All right, so Tim teaches Alice GeoGebra is our topic, and the hashtag that we're using is hashtag GGBchat, and Tim will check that hashtag after the webinar and answer any questions you put. And if you're watching on YouTube, I am watching the chat stream if you want to put any notes in there. And this is Tim. So Tim, want to talk about yourself?
Sure. Really quick. Hello. Thank you, Alice, for having me. I'm Tim Brzezinski, GeoGebra's Professional Development Director. Prior to that, I was a full-time high school math teacher and part-time adjunct faculty at a local state university here in Connecticut. My passion is empowering teachers to empower their students to become active discoverers of the world of mathematics around them. I love it when I can just simply be in a classroom where kids are having those aha light bulb going off over the head moments. That's what I live for when I'm in the classroom and working with teachers and students. And so I hope that what we explore today will help you out as we are in this unfortunate time of distance learning. So.
Yes, and can you explain the QR code?
Yes, that QR code right there. I post a lot of ideas for teaching and learning on an almost daily basis. So if you snap a picture of that code with your phone, you'll be given links to my Twitter, YouTube, Instagram, and Facebook pages. You could like, follow, whatever. If you ever have questions, you could also send me an email. I'm not sure if email's on there, but it's tim@geogebra. Oh, it is. There it is. Perfect. So yeah.
Okay, cool.
Yeah, and if this is an awesome group that I help moderate. GeoGebra created it, but if you have questions the day in, day out teaching and learning of GeoGebra, please join. Don't forget to actually scroll down the whole thing. A lot of people don't see that I agree, you know, when it comes to like the guidelines. Basically, it's not a self-promoting page, or it's not a whatever, but we don't bash anybody, but it's an environment of respect and simply just saying, hey, got a question about GeoGebra, how can I blah, 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 or some teachers say, hey, I did this, want to keep the dialogue going. So it's like a support group, and it's a way to meet colleagues and have fun. So
that is what we are, or I am recommending, that if you are saying like this webinar isn't what I was hoping for, I want information on this, the Facebook group is a great place to go. And it's a place that you can find out when Tim's webinars are. Is that right?
Yep. Yeah, I always post stuff there. And if I can, before we start, can I actually post the link, that tiny URL to that one slide, Google slide that has everything? Yeah, let me share and before we start, so people have it before we go. There we go.
Sharing. I'll let you share.
Okay, so we'll share. And so, ladies and gentlemen, if you're willing to just you can go there on your phone, or it's the same QR code. I didn't realize Alice would have had it too, but if you type that tiny URL in really quickly into a new tab or something, tinyurl.com/GGBlots. Okay, because lots of resources for you here. So this will take you, that tiny URL right there will take you to a one-slided Google Slides document that looks just like this, okay? And basically 4 hyperlinks here. If you're interested in the webinars that I have facilitated in the past and see upcoming ones, click on that. Every image is a hyperlink. So you can go ahead and click on that one. Elementary, middle, or high school, GeoGebra, we are actually releasing these 3 links to GeoGebra's webpage, homepage, sometime next week. So they're within easy find. Now there's over 400,000 or more, even 1 million, I think, GeoGebra resources that you could find on the platform. But I and the team and I, we've gone through thousands of them and looked through and filtered out whatever. But a lot of ready-to-use resources that you could use especially to foster student-centered learning in this era of distance learning, and also in the classroom when we're back. So, but feel free to keep that open right there. But that's feel free to access that at any time. So, and I'll post
to this.
I'll post it. I'll post it right here.
/GGBlots. Can you just real quick bop over to Twitter and put that on the hashtag that we shared?
Okay. Yeah, actually, I'm not gonna do that right now, only because they're actually still technically shared with link status, but I'm figuring the webinar I threw it. But next week it'll be out, and I know GeoGebra is going to make an announcement, so it'll be cool. But over 2,000 resources you could use right now. I mean, the stuff that's inside of it is all public anyway. It's just that the links to all that's private, but whatever, doesn't matter.
Right.
But you could, if you're watching the webinar and you see it, go ahead and have at it, start exploring and have fun. So yeah.
Okay.
There you go.
Cool. All right. Go back to full screen mode. And as we already said, that this is Tim teaching me. Hey, Dr. Brownell joined in. So we'll
He's
have
here.
him introduce himself. Tim, what's this tinyurl.com/Tim webinar?
I have no idea. That was from last week.
That was from last week. Okay, forget that then.
Moving forward.
Moving forward.
Hey, Chris.
Okay. So then Chris, why don't you introduce yourself, please?
Okay, sure. Hi, I'm Chris Brownell. I'm a math professor and a math education professor at Fresno Pacific University. And I'm kind of here to just sort of monitor the conversation from people and interject while these two talk to each other and talk to you and model how to learn to use GeoGebra as a teacher. So that's my role, is just to sort of be the weird.
And he is the co-author of the book Math Recess.
Math Recess.
Yeah.
Okay.
Yeah.
So Tim,
I know, work on my marketing.
All right. So why don't you go ahead and share your screen, Alice? All right, and go to geogebra.org.
Yes, let me stop Chris being the spotlight speaker. Cancel that. All right, now switch. Okay, I'm going to share my screen. And I lost, oh, no, there it is. Okay, you see it?
Almost.
No, I don't even know where it went. Apparently I'm too dumb to use my own computer. Oh, I see it in screen mode. I hate that.
There we go. Got it.
Now we good?
Now we're good.
All right. I'm ready to do it.
So let's go to geogebra.org. And I got to challenge you. Could we do this webinar having a maximum of 5 tabs open? You're probably going to tell me no, huh?
And my standard line is if I have less than 42 tabs open, something is wrong.
Oh man. Okay. So Alice is logged in here. Again, if you're joining us for the first time today, it's okay. Parts 1 and 2 are not prerequisite for what we're about to do. Parts 1 and 2 are on Alice's YouTube channel for the previous 2 that we did. But if you don't have a GeoGebra account yet, take a minute and go to the upper right corner. Notice the URL is geogebra.org. Where you see that big green A or that white A, you'll see a sign in icon. So go ahead and take a second to sign in, because the reason why I'm asking you to do that is so you can save any constructions that we make today and you do alongside with us. Fast, if you don't have an account, go there, hit create account and do it through Google. No password needed, obviously. But
okay, so what are we doing?
All right, so last two sessions, we actually explored GeoGebra's resources or activities that other people have made. We made ourselves, did that. Today, we're gonna take a mile-wide, 2-inch deep exploration of a few of the apps, only a few. We're gonna look at 3 apps and do a couple basic things.
Okay.
To have, it sounds like a lot, but we're gonna go slow, all right? And see how easy these apps.
Can I ever go slow?
Huh? Yeah,
He's not slow.
I'm not either. So my wife was telling me to talk slower, but could you click on those 9 squares in the right corner, please?
Slower and quieter. What am I clicking on?
Next to the bell up in the upper right, next to notification bell, go to the squares right there. Yep. Let's open up the graphing calculator.
Graphing.
First one.
Oh, the first one.
It's
that
Friday.
top one.
I thought it was a title.
Now, don't do anything yet. Don't hit it yet. I want people to know this because this change came February 6th, and it drove the Twitter world nuts. And the thing is that right now, a lot of longtime users of GeoGebra who have used this app, it actually frustrated a lot of people. But GeoGebra did this because there are several districts in the United States now that are looking to use GeoGebra on high stakes standardized or summative assessments. All right. One example is the Sewanaka Central High School District in Long Island, New York. They were an all iPad district. They applied for the Regents Board, the Regents exams in New York, and they got permission to actually do just that. I love that picture of you and Joe Bowler. I just know you're not sharing your screen anymore.
I know. I had stopped the video because I needed to get something. And
no, it's fine. It's fine.
Apparently, it was complicated to get the video back. Whatever.
Gotcha. So
sorry.
long story short, I could tell you from GeoGebra's end, again, I'm not a salesperson because if I was, I'd be doing a crappy job, but GeoGebra's apps, GeoGebra's graphing calculator is compatible for high stakes exams. I mean, yes, in Europe it's different, but in the US, we still have a lot of districts that want students to do a lot of rote calculation by hand. And again, that's a topic for a different webinar, but the point is those realities unfortunately still exist. So because of that, GeoGebra actually eliminated all geometric construction features from this graphing calculator. And so this is like the equivalent of a TI, Inspire or whatever in full-blown exam mode, if that makes sense. But it's the feature, it's a lot easier to do things. But we can still discover lots of things in this basic app. If you want to construct, say, perpendicular bisectors, go to the geometry app. It's all there. So I just wanted to make that very clear to people. So yeah, so let's hit OK.
Okay.
So now let's actually so obviously right here, this is the app itself. So I never always had my students go to something that I made and crafted with questions and animations.
Oh.
I just had them go play and build, which I think is a much more natural way to go. So let's hit the X, the keyboard down there. Just hit the X there.
Okay.
All right. Now let's just type in, say, in the box, type in x squared minus 5x minus 1. Right. Again, look how fast that is. Right. Now, notice you could just like basic things. You can basic things like in other apps you see that if you click on the gray dots there, go to the port. Yeah. So if you go to the gray dots there, see on the graph, click on any one of the gray dots.
Oh, those dots.
Yeah. So you get that stuff instantly. Think of how much faster it is than going to one of the old clunkers, left guess, right guess. Again, I'm not here to put any, competition down, but the thing is, I've worked in schools where people are off the grid. Hey, I'll take what I can get. But the point is, if this is available, why not use it? So it's easy. Let's type in a function with infinitely many. So type in sine x, say. Just type in sine x. Repeats, right? Or just type x right there.
That doesn't seem right.
No, just you got to actually fill in that thing there. Yeah. And so notice if no matter how far you zoom in or out, you could click on any one of those gray dots, you'll see values instantly. Okay. Yeah.
What did I do? How did I lose the dots?
No, you just got to touch the curve anywhere.
I have to touch the curve.
Yep. No, hit enter. See sine x. There you go. There you go.
Click on the function on the left side. There you go. I got it.
There you go. Now you could also do things. Let's actually type x squared. Go to the third input. X squared plus y squared equals 4, for example. X squared. Yeah.
I haven't had enough coffee yet today. Oh,
Not yet.
What?
All right.
Sorry, what did you
Now,
want to do?
it's pretty cool, right? You see where the circle and the parabola intersect? So why don't you just touch right there where see the point of intersection? Yeah. Just think of how more complicated it is to get on a handheld, right? In GeoGebra, it's quick, it's nice and easy. You can get both points of intersection right there. Okay. It's user friendly, which it should be. Now, I'll even show you a little quick trick here. That's pretty nice. Again, this also works in some other apps too, but let's type in, go to where it says input now. And let's actually type in 1 million without the commas. Or 10,000 or whatever. And then open parentheses.
Wait, there we go.
Yep.
Okay.
No,
I have
no,
to do
yeah. Yes, 1 million. Open parentheses.
open parentheses.
1 plus 0.03 over 365. Now use the right arrow to tab out of the parentheses. And then hit the exponent, shift 6 or whatever like that. And then notice how this is a fast calculator. See how that exact value is still a number, so it's telling you what it is. Now type in 365x and enter. Now we just graphed the function there. Could you actually turn off the bubbles for the ones up above, please, and hide the others? Just so I can see any of that for now. Now, any teacher teaching compound interest knows that's kind of a popular equation. But before you do that, hang on, I want to show you something even better. Go ahead, hit zoom out a few times. Hit zoom out. I always ask students to get a good window for me, right? And so you, the student, are doing this and say, oh, Mr. B, I got a good window. But I'm like, yeah, you know what? You're 3,000 years in the past. If you pan off to the right, you're 3,000 years in the future, right? Well, can you go to where it says input and type one more thing here? Let's type in y equals 2 million. I want to see how long it takes for it to double naturally. Okay. So there we go. So can you get me enter? Can you get me a good window now, Alice, with both of them there? And teachers that are watching, you know that sometimes you want to make an aha moment for students to just get a good window for them takes an eternity, you know, but you zoom it out and zooming out and zooming out, and eventually we'll see the horizontal line, right? But man, that's kind of ugly, right? So why don't we zoom back in again? I want to show you a little nifty trick here. Let's zoom in.
Hey,
A
does
lot.
pushing the home button zoom
Yeah,
something?
hit home, yeah. That's like the typical -8 to 8, -8 to 8 sort of thing. So now, Alice, here's what I want you to do. I want you to press down Shift on your keyboard. All right. And then I want you to go to the positive y-axis and move it down. Right there. See, now you can change the scale. So I feel that for kids, this is a much, while you're holding Shift down, yet I feel that for students, this is a much more natural means of exploration to actually see, you know, because getting a good viewing window there's a lot of teachable aha moments, basic for kids, even in that kind of context there. You know, what kind of window would be good for viewing? But let's actually keep holding it down. Keep pressing Shift. I want you to get a really good viewing window for me. Really good. It might take you a couple presses. I probably should have told you 10,000 instead. That's all right. There we go. Now do the same thing for the horizontal axis. Hold down Shift and just kind of, there you go. And now you can drag in the white, move it where you want. All right. Now, to me, that's way more natural than going to a second screen off to the side, X-min, X-max, X-scale, Y-min, right? Because kids are clueless. They got to go to a separate screen to see it. But in GeoGebra, we can do it all here right now. Now, touch where they intersect. You'll see it right there. It takes about 23 years for it to double naturally. Okay.
That's
so
fabulous.
I love it. Okay. So just basic stuff that makes people happy. Now, there's a cheat sheet here way. If you go to the settings gear, upper right corner, if you go to zoom to fit, that's kind of like the TI equivalent of zoom fit. You know what I mean? So on a standardized test, then yeah, you know, but I don't usually tell students that unless somebody discovers it and okay, we'll see it, you know? So even in the mundane day in, day out things that students often do on a TI or a Casio or whatever still is out there, you know what I find is a lot easier to do in the GeoGebra graphing calculator. All right. So,
but that's not as good a picture as what Alice was able to drag.
Well, you know what? I'm not sure why it did that, honestly. There is some kind of algorithm that, again, I'm not a developer. I have no clue, but I got a picture, and if Alice wants to, she could always drag it up a little bit, you know? But yeah, good point. So now, can you actually refresh the page for a second, Alice?
Refresh? Okay.
Yeah. Now let's go to the tools there. So go to the circle.
Like that, everything I just did?
Yeah, I wanted a clean palette. So let's go to the tools.
Wait. You know, so what do I need to do to make sure that that saves? Like,
oh, sorry, it didn't save. My bad. I didn't know you wanted to save that. Let's make a construction now and save it.
No, not uncommon that your computer freezes up and you refresh.
Okay, so
what's your best tips on that?
I would save it off. I would just save it as often as you feel like. I mean, when I'm working on something, I build complex constructions in the web-based apps online. And if it's really complex, I'll save it after typing 2 things and it's quick, you know. You know, it's not like the Google, which automatically saves, you know, yeah, but it's not, you know, to me, it's not inconvenient.
Where do I save it?
Oh no, let's say, let's just plot a few points on it. Let's just mess it up first a little bit. Okay, so there you go. If you want to save that, go to the hamburger menu, upper left, and go to save, and call it what you want. Now, if you look at those things there, then say that it says saving, now save successfully. Now I can share that, and I could share that in my Google Classroom. Everyone in the class will get that. And when I do that, actually, let's suppose I had a graph right there. If you gave kids that link in Google Classroom, students, if they have GeoGebra accounts, say some districts, a lot of districts let them, they can actually sign into GeoGebra, open up that graph, and modify your construction ever so slightly and give it right back to you. It'll be a brand new URL.
Can you say this slower about free versus logging in versus I didn't know this. A school can have an account with GeoGebra, like.
Yeah, well, I on Twitter, I interact with, I get emails from teachers. When I see people ask me questions on Twitter, it's like, okay, well, what do I do? My students, my kids cannot have GeoGebra accounts, you know, because there are districts out there that will not let their students use their school-based Google account to create a GeoGebra account using that school account. I mean,
just in the briefest way possible. Why?
Because, well, there are some districts, unfortunately, that Google districts, there are some districts that will not allow students to create accounts with third-party apps, even reputable, trustworthy ones like Geogebra, which is unfortunate.
That's very
But they do that. But many districts do allow that. So if you are a teacher in a Google school and your kids can create a Geogebra account using
like,
Google.
they create a Geogebra account. It's not like someone calls up a Geogebra rep and it's installed like if you had Hapar or something. It's not like that. It's
No, I mean,
single sign on. Like if I used quizzes and I log in with my Google account. That's what you. Okay.
That's what I mean. Yeah.
Oh, okay. So I literally was very confused about this.
I'm sorry, I wasn't clear.
that there is a specialized Geogebra account. There is no Geogebra account. It's just the logging in or not logging into Geogebra, whether or not your district allows it.
Right.
And if they are logged in, they can manipulate the things that you create.
Right. Well, actually, yes and no. Let's rewind back 2 seconds. If anybody can go on YouTube and watch a video, logged in or not. But if you want to upload a video, you need an account. Right. So likewise here on Geogebra, if you do not have a Geogebra account, then you cannot save any construction that you make. That's why on Twitter last week, I posted a resource for teachers that were frustrated. My kids can't make Geogebra accounts and I want them to save work on Geogebra. Then I create a solution for them to do it through Google Classroom, having blank templates to assign there, which I could put.
So can you just say that statement about Google Classroom slower and clearer, that if they do not need.
Yeah, you do not need. Hey, bud, go see mom, okay? I know. Go see mom. Go see mom. Close the door. Thank you. You do not need. Okay. If
live television.
Exactly.
This is live television. That's for sure.
Live television, ladies and gentlemen. Yeah. Let me. If it might be easier to. Can I share my screen for just 1 second?
Yeah.
Since we're on that detour. All right. Let me go here. Share. Okay. So I'm going to go to Geogebra. Okay, so I'm logged in as me here. I'll go to my profile. So right now, if I want to go to, as Alice did, I can go to any app and make something quickly and go to File Save. Because I have a Geogebra account, I can do that. But if students are in districts whose administration will not let them create a Geogebra account, then that's a problem. Work will not save. So if you are one of those teachers and you want to have your students build in Geogebra's apps, you can still do that, but you will just simply need to use one of these templates here, which I will actually. Where should I put the link, Alice, for that?
I don't think we have a place that you could really do it. The YouTube live stream doesn't let you put links.
Okay, but after the video is done and processed, can I just give you the link to drop in the description?
If you put it in the chat, I'll put it in a YouTube comment right now.
Okay, perfect. Thank you. All right, let me just do that, and I'll have Alice share again. Whoops. All right, here you go. Dr. B, it's all you.
I'll get it.
All right.
All right, I have the description open right here, so I can actually just add it. What is this link that I'm putting in the description?
This link right there are links to 4 blank app templates: the graphing calculator, which we're in right now, the geometry app.
Save. All right. Now in the description.
Okay, the 3D calculator and the classic app. But basically, those are 4 apps that teachers can assign as tasks in Classroom, and that way students have to go to Google Classroom, of course, right, to do their work. That way their work saves in Classroom, and they don't need Geogebra accounts to save work. So that's the easy way to navigate through that.
That's
if
awesome.
That makes sense.
Okay.
So.
All
right. But I want to do a quick discovery lesson with you that takes not even 5 minutes about correlation. All right. We'll do it in the graphing calculator. Oh, by the way, could you type in one more function? Just type in an input. Just type x-2 or something like that. All right, and enter. Go to the snowman off to the right of x-2. Snowman table of values. So I just want to show teachers that really quickly. The basics. You could make a table just like you do on a handheld. Okay, and there it is. All right, and notice it actually shows a sequence of dots on the grid. Okay, you could hide it, you could show it. Again, you could have multiple tables there because we want students to look at functions in different ways. There you go. All right, so let's go back to the calculator, please. And this is an activity that I'd love to engage my Algebra 1 students with, and they discovered it in 5 minutes. Alice is gonna role play the student. I'm gonna role play the teacher, okay? And I'm gonna actually have her discover what the concept of correlation coefficient actually is without her actually Googling it, all right? So could you actually delete those?
Degree in math.
Huh? What's
It's a
that?
little unfair since I have a degree in math.
I know. Well, I like to role play with teachers all the time. Then we talk teacher to teacher. It's fun. But could you actually delete those, please? You could just
Delete.
Yep.
Okay.
All right. Let's right click in the white. Right click in the grid there, and I want you to turn off the axes.
Right.
Or go there.
Oh.
Uncheck show axes. Yep. That's all I want. I just want you to have a grid. Okay. So we're not even doing X, Y, intercept, none of that stuff. All right. So would you please just go to the point tool, the circle triangle. Just plot a bunch of points, like plot 7 or 8 points, anywhere you want.
Do I just click on?
Yep.
I don't know this tool.
Yep. So just click on point and just click anywhere else, and it tells you what to do. Click anywhere in the white. Just plot 7 or 8.
Okay.
Okay. Now what I want you to do is scroll down the list of tools there a little bit, please. And would you please find the one that says list? It's that one right there. You just passed it. Last one. There you go. Now we're going to, remember on a TI or on one of those others, you actually will put like data in a list, your L1, your L2 and all that rigmarole. Well, in GeoGebra, it's much easier to do than that. Click on lists, and all you got to do now is highlight a rectangle around all those points you made. Drag a box around it and let go. Okay. Now go back to the calculator on the left. Okay. See how the list is called L1 right there? Okay, now what I want you to do is where it says input. Now, next line. Now, granted, you could have manually typed that in. Some people like to do that, type the command instead of using the tool. But I'd like you to type the word correlation, C-O-R-R, and just hit tab over, hit tab. All right, or hit enter, I should say. Sorry, it'll populate it. Now, can you tell me what the name of that list is?
It's L1.
So type L1. Actually, here's a little advice. Don't delete, just type over that. Okay? Because you're making more work for yourself.
Okay, that didn't work.
Okay, so delete that thing right there. Delete that row. And delete the correlation slider you just made accidentally. That's okay. Everybody does it. So type in correlation. Click on that. Now type L1. There you go. Enter. Now, would you look at that? Now, granted, we're rounding the 13 decimal digits. By default, it defaults to what like a traditional handheld calculator would be. I'll show you how to round that later. But here's the task I give students, open-ended task I give students for a few minutes. I tell kids, I want you to pair up with the person next to you, right? And what I want you to do is drag those points around, and would you please make that number A as high as possible? Go. And so the students get to work, right? Their goal is to make that number as high as they possibly can, right?
Okay.
And some students discover it in a matter of 60 seconds. Some students need 5 to 6 minutes. So what? Not everybody works at the same rate. We as educators know that. But see, an app like Geogebra Graphing Calculator allows students to simply manipulate points. Try doing this on a handheld. How do you manipulate data on a handheld? You got to go to a table that you can't see the graph anymore, right? And then try to change a coordinate and kind of hope for the best. You know what I mean? But Alice, it looks pretty good. You're getting a little closer. But what can you tell me about those points from what you see?
Well, they're obviously lining up.
They're starting to line up, but what could we get even higher than 0.99231? Blah 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 blah. How could I line those? Can you line them perfectly up?
Manually?
Yeah.
No.
Sure you could. Just go to a corner of a square.
Go to a what?
Just put it on the corner of one of those squares.
Oh, you want me to tediously just do that?
No. But students are like, I got it higher than you. It's funny. Some of them actually kind of fight with each other and say, okay, there. Right? Look, we're getting better and closer. And then finally, almost there.
I feel like I'm missing some.
C is off in the open there. So you move that Ah, there we go. Ding, ding, ding. And so, and I'll walk around. If students have that, they see it. And now, so tell me what that means. And so the kids see, the thing is, I'm not talking to students. Think of how we often teach this. We end up, a lot of teachers end up giving students this looks like, blah of information. Here, if R is 1, it's a positive correlation. They all line up perfectly. Instead of lecturing and delivering and
That's how
delivering.
I was told.
Right, right. And so I like to have kids tell me. So anything, and I tell teachers, like, aha moments don't have to be deep and elaborate. They can be simple and take 5 minutes. In an app like Geogebra Graphing Calculator, this is powerful. Now, and so, and I'll have a student. Now, I'm not one about taking notes or something like that. Teachers about like, did you take those notes? And I'm like, and I'll ask teachers all over. I say, do you think just because a student wrote something down means they're going to magically remember on a test? We've all had students where some kids don't write anything down. They're the ones getting straight A's, and even students that bust their butt and work, they earn C's, So I don't think there's I'm not going to drink the Kool-Aid and think that, well, now I'm not devaluing the importance of writing something down. Yes, there is value to that. But
For some
people, yes, I'm not going to say it for everybody, but the point I'm trying to make is that students can actually save this, go back to it. They can modify it again and remember. But see, I am taking info from the students and then they're putting the couple of pieces of data on the board. I'm just sitting there, just driving, like kind of like egging it on, if you will. Now, my next question to students is, all right, you made that number as high as possible. I want you to take it and make it as low as possible now. And now you see where I'm going with this, right? And so we can look at different screens, and Alice, your line has a slope of 1 right there, does it not? But some kids will have a slope of 1/2 or 1/3, whatever, but we could see, gosh, it doesn't matter. Like we say positive, negative, that kind of thing. A lot of rich discovery here. It's pretty powerful, if you ask me. But,
and there's no way to, now we're talking remote learning. So like in a face-to-face, I'd have maybe a way to have the kids see that not everyone has the same, which are two properties I highly value is, obviously discovering instead of being told. Math is about pattern finding. That's from U Cubed. And then valuing different approaches. And so how maybe would you do this in a remote learning situation where the kids aren't looking at the same, or are you doing this like on a live?
That's a great question. No, I could teach this. I would actually, when I interact with students, this is something that I would give just live. If I was still a full-time teacher and my Algebra 1 class was with me and they could share their screens or whatever, I'd say, hey, I would actually probably save time and just create the dots, like you did at first, blah, blah, anywhere I want, save that file. So go ahead and go to File, Save. I'll walk you through it again. Go to File, Save. Actually, make sure they're not lined up, but you know what I'm saying, but go to File, Save, right? And sample with Tim, call it, you got to change it, otherwise they'll overwrite it. So, there you go. Save it. Now, it creates a brand new URL up top, it changed. Now you share it. That's what you're going to drop. That's what you're going to drop in the chat when you're having with the kids. I want you to work on it on your 30 computers. You're all in video conferencing, and hey, what do you see? Everybody's actively exploring.
Now, if you were to do this through Google Classroom where you push them all a copy, then you would be able to see them.
Well, I would have to, I define see them. What do you mean? I mean, once they hit submit, yes. Like, for example, if now you took this, let me see here. If you actually, well, what you would have to do is go to, can I share my screen?
Yeah.
Yeah. So, or actually, two answers to that question. The first answer is yes. If your student could create a Geogebra account, mess with your file, mess with your app, mess with your graphing calculator construction, and have I got it when it's 1, right? Then they could save it to their Geogebra account, give you that URL, you're set, right? But for a teacher in a district that does not let kids create a Google account with third-party apps, right? Because they're out there, unfortunately. Then what you have to do is this. You go to one of those templates that Dr. B just dropped in the YouTube chat. I'm there now. Oh, it's the graphing calculator. And this is what Alice, this is what you and I talked about, I think the first session we had. See how I have a blank template here? But what I'm gonna do now is go here. I'm gonna copy the activity.
Okay.
And then I'm basically gonna do what you just did right here, right? Make a template for my kids to work on. Let me hide the axes, right? And then after that, I hit save and close. And so now to find that copy yet again, I go back to my profile. It's right here. All right, what's going on here? Hang on. Oh, I didn't save it in the, it's not GeoGebra, it was me. I'll show you again. Sorry. So right here, graphing calculator.
Mhm.
All right, I'm going to copy this activity one more time, just like I copied Google Doc. And I'm going to say, hey, CC Discovery. And then I'll go ahead and I have to go in here. I have to go to where it says edit applet. That's the one part I forgot to tell you. I apologize. Edit applet. Now it's like I'm working, because if I don't, it's not gonna do it. So right here, I'll make the points for my kids. Turn off the axes, hit done. See how it's there right now? And then I hit done, save and yeah, done right there. Save and close. All changes saved. If you click on your name, you can just click on your name. It goes right back to your profile there. So CC Discovery, see how it's got my points on there. Now I, the teacher in a Google school who won't let my kids create GeoGebra accounts because that's just who they are, I can go to share in my Google Classroom. And now what that's going to do is create copies for all the kids in the class. And we showed that on the first webinar that we did. So I have to go through that way. If they want to see it, they can watch that one.
Good.
Okay.
All right.
All right. So let me stop my share. We'll get right back to where you were, and we'll visit another app now. Are there any questions? I've been monitoring GGB chat. Nothing here.
No, it's been pretty quiet.
Okay.
All right. So I'm coming back there. And what are we doing now?
So let's actually visit the geometry app. So click on GeoGebra right there. I'll go back to home base. Yeah. There is another app called the Geometry app. We're just going to look at geometry for a few minutes and then 3D for the last 10, and then we're done. Geometry right there. A second one in. That is another app that GeoGebra has. That I love this app. I find this to be the most kid-friendly app actually. For elementary school teachers, you want your students building, shapes or whatever like that. So could you just go ahead and mess with the tools, if you will? Just play around for like a minute. Yeah. Show me what you plot points. Easy, right?
Oh, hey, there we go. Look at that.
Yep. You name the point Alice and the value. And I ask kids, well, what does it say when you, oh, the value of a point is its what? Oh, it's coordinates, right? See, every object in GeoGebra has a name. The name of that point is Alice. The value of that point is its coordinates. Oh, so the thing is in the geometry, doesn't this look just like the graphing calculator, but it's kind of like you don't see the grid at first, right? This is more of a natural, it's very natural. Aren't those the basic building blocks of geometry right there on the left? You don't see all the tools at once, so it doesn't overwhelm you, okay? But you could have kids make and play things, and play with things, right? And so actually, yeah, so would you actually hit the blue arrow for a second? I want to see if you can touch them. Could you touch the line you just made?
The line I just made.
That one, yeah. Click on the line there. And look at the style bar. Let go for a second. I'll go to AA. Hit show value. That's the label. What is that? The value of a line is its what? Equation, right?
Fancy that.
And what do you think predict what the value of a segment's going to be? Do the same thing for a segment. What do you think the value of a segment's going to be in GeoGebra?
It's magnitude.
Right, or length, right? So now let's make a circle and see what the value is. Can you do that for me? What's the value of a circle in GeoGebra?
Okay, wait.
We got to turn the tool off first because you're going to make a bunch of circles. Yep.
Okay.
There you go.
All right.
Or that's the point, I think, not the circle. That's okay.
Okay.
There you go. Yep. It's equation in standard form. A lot of people think it's a circumference or it's like, no, it's actually the equation. That's the equation. Now, do you see why this functionality had to be turned off of the graphing calculator? Because a lot of state departments of ed are the way they are, can't show it, but at least here, if you're going to discover, this is a perfect app to do it in. If you go to Polygon, for example, let's discover quickly that the angles of a triangle add to 180 by building. Click on Polygon and just make a triangle. So start 3 and then close it back at K. Oop.
I double clicked. Was that not the way?
That's okay. Just hit cancel.
Okay, so no double clicking.
You can double click all you want. All right. So turn it off by hitting arrow. All right. So can you make that triangle a little bit bigger? Because it's gonna be hard to see stuff there, right? Make it a little bit bigger. Let's drag them out. Let's make it really large. Okay. Again, if you go to the, can you go to the calculator now? I want you to see something pretty cool. Notice how those elements there, they are qualitative descriptors and not quantitative. In the graphing calculator, you see equations and stuff like that. But for elementary kids, you know, that kind of overwhelms them. This is pretty, like, I love the qualitative descriptor here. You know what I mean? Kind of, to me, logically, the GeoGebra logically made sense, you know? But let's actually measure the angle. So can you find the angle tool quickly?
When you say qualitative, you mean it's actually a descriptor of
Verbal
the object
descriptor.
itself.
Yeah. Because if
Okay.
now I can actually change, we could change the settings in the settings gear to say, you know, to show definition and value, they call it. But actually, it's easier than that, Alice. Just click on angle and touching the triangle. There you go. Right now, hit the select arrow. We'll turn it off. I think you have two 78.2s there. Can you actually get rid of one of them? Maybe you probably did that one first, but that's okay if you didn't. Yeah, just click delete. There you go. Okay, so now let's go over to the left. And I would give my kids, all I did, my students would come to class. What Alice is doing now, I'd have them do this very thing. All right. I had maybe a Google Doc of like 4 or 5 steps. I'd have them build it, make it. But see, by a month in school, they already knew how to use Geogebra already.
So
Because I gave them the first week to play.
You would do this in a Google Doc with the directions instead of creating one of those pages like we did the first week, where I put the steps.
Oh yeah.
Calculator.
Like, and that's every teacher's personal preference. When I was full-time teaching, I like to have maybe like 6 or 7 directions on paper to discover, but I would actually have the kids on the screen. Again, as you say, paperless is not a pedagogy. Like I preferred to have the paper directions on paper and have my kids playing GeoGebra. Some teachers are not that, and it's not right or not wrong. It's just different, you know? But let's go to the calculator. We're going to add up those angles now. Okay, notice how GeoGebra gave them Greek letter names. And some teachers will tell me, oh my gosh, I said, listen, a lot of your kids are the ones that are like figuring out how to get on sites, the school blocks. Your kids can learn a little bit of Greek as far as I'm concerned, you know? So let's go to the, let's go to input for a second.
Okay.
All right. Now you need to actually touch on the keypad. You see the lower left corner there? Let's let it pop up. Where are the Greek letters? So where's alpha? The first, actually, what's the first angle there? Can you scroll up on the left? What was the first angle? Beta. Can you find beta there?
Oh, here it is.
There it is. And then plus. And then let's type the plus. The plus is under 1, 2, 3. Or you just type it. And then gamma, right in the middle. Yeah.
It's
and
all
then plus.
Fonts don't match.
Say it again.
Why don't the fonts match?
I honestly don't know. That's a good question.
Right.
And then plus, what's that one? Delta? Yeah. And then enter. And look at that. Now hit the X for the keyboard. By the way, that keyboard is vital for iPad districts, right? You need to type on that. Yeah. And it's powerful. So now why don't you move the angles around and see? And oh my gosh, 3 changing angles, the sum remains invariant, right? And so after that, what I'd have my students do is make 3 or 4 different GeoGebra constructions. They do a quadrilateral, a pentagon, a hexagon. They notice the 180 pattern going on, right? Okay. They tabulate the data. And then I ask them, okay, hotshots, I love what you're doing. We're going with this, but I want you to find out the sum of the measures of the angles interior of an 83-agon. And they look at me like, oh, it's just 180 times 83. Dude, think about what you're doing. You know, go back and look at it. But see, contrast, I'm not saying I taught perfectly, but I'm just saying I'm trying to create an environment where students are building, they're gathering data, they're discovering, right? And the n-2 part came after that. You know, they discovered if I take away 2 from the number sides first, then multiply by that 180, I get the sum.
So
right?
I literally, when I make math lessons, I make a brand new Post-it note every single time, and I write on it, math is about pattern finding. And I don't reuse my Post-it because that's different than how I was taught. It's so hard. You just feel like it's so natural, like breathing, and you just want to say it like they should just know it. But
I know.
The reason I know it like breathing is because I've been teaching it, right?
Mm-hmm.
The only time you ever saw it was when you were in high school. You're never going to remember it unless you discovered it in some way. So I remember a lot of times my friends would try to help me when I was doing math, like, let me just tell you how to do it. I'm like, no, I need to derive the equation. Like, I want to derive it, because if I don't derive it, I actually don't own it.
Right.
That was me. How I approached doing math is I just stubbornly like, no, if I need to figure this out. So that's kind of like my driving force for lesson planning.
Right.
So there's a question, and I think it's a good place to open this discussion just a little bit. How do you prevent kids from rushing through this experimental phase to the so-called end?
Well, the thing is that like, good habits take, a few weeks to develop. But if as a teacher, it's like one of my goals is to get my kids in the habit of constructing. I would be that parent of 9th grade honors geometry students where you have all parent night, they come in, you know what I mean? Like, it's standing room only and they want to hear about you and whatever. But it's like I tell these parents, listen, just because you think that if your son comes home and complains because they can't solve that math problem in 5 minutes, it does not mean they're stupid. It does not mean they can't do math. But see, they've been brought up all throughout the years that they thought that, they're just quick, they think fast processing means intelligence, and it doesn't, right? So it's like, but I say that in my class, your son or daughter will have problems that will take them more than 20 or a half hour to solve. Maybe they'll think about it at home afterwards. I mean, but the point is, where it's a constructive learning environment, and the more I talk to kids, usually it wins them over. I even tell kids this. I say, you know what? Those of you that say watch the series, remember the show Dr. House, the series House, like that episodes.
Mm-hmm.
What made the show House so interesting? Well, there was a problem whose solution was not immediately apparent. And so they would go through the whole show and see, like, wow, why is it like, and then House, they have the epiphany towards the end of what's wrong with the patient. Well, you know what? If Dr. House was like, if Fox decided, or whoever did it, it's like, House is on clinic duty, take some aspirin, you're done, we would never watch the show because that'd be boring. I don't want a boring math class. I want a House math class, if that makes sense.
Yeah, anyone who says to me that they're not good at math, I'm like, really? I don't
Right.
believe that is true. And
Right.
it's like, it turns out they just don't like boring math problems. And so I go to open middle and I find a problem. It turns out, of course, they like math, and of course they're a thinker, because thinking is
Right.
fun. Remembering and memorizing is remembering and memorizing.
Right. No, I know. And I go ahead, Chris.
I'd like to, I just want to go back to one of the first things you said in your answer, Tim, was I like to get them in the habit. And it really is, it's a habitual practice that you
Mhm.
have to form and help them form. And it also means having to break old habits, right?
Yes.
You've got to help them replace bad habits with good habits. And that
Totally.
takes time.
Totally. And it's
That's
funny
what
because like it got to the point where a couple months in, students like, Mr. B, do we like, why is it always true at the angle here? Was it and I'm like, how do you think I'm going to answer that? And the kid rolls his, go to GeoGebra, never mind, it's like, or go ahead somewhere. Exactly. But no, I want to respect the time here. I know that we're not going to get a chance to look at 3D, which I would love to show you, but I know time isn't going to allow. But if I could just show you one more thing quickly. Could I screen share, Alice? Is that okay?
Yeah.
All right. So this is one thing, and just to show you the power here, that what you can do within this app itself, but let me just share quick. Right. In GeoGebra's apps, some people may not realize it, but you can, let me go to geometry. You can actually you can actually just simply drag a picture in to the app. So right here, in my old, say, hometown, Connecticut there, I just dragged the picture there. Look at that. I ask students, like, well, let's talk about competitors in business. Those spots are in central Connecticut. Those are Home Depots, right? Now, Home Depots were built proactively. They came first, right? But who came along about 10 years later and tried to give them competition? Everywhere you see a Home Depot, what other store do you always see?
Lowe's, I assume.
Lowe's, right? And so there, in my old hometown of Stellington, Connecticut, there's actually 2 Home Depots, one here, one here. And so I'll give kids a map and say, you know what? And by the way, you could drag a ski jump in the graphing calculator, plot points, and do a regression that way. It's so easy, it's pretty cool answer. But like here, if I'm like, say, right here and right here, where would I actually want to put my Lowe's in order to be to give both of these stores some competition? And what do you think? Was that?
What a great question.
Oh, thanks. And so most students would say, well, Mr. B, you just got to put it right at the midpoint. And I'm like, yeah, well, my old elementary school is right off Hart Street, and you're not going to knock down Kelly School like that. They can't allow that. It's literally right there. So I said, okay, well, I'll tell you what. So, and then they go back to the geometry. Oh, wait, equidistant from 2 points, locus. Oh, perpendicular bisector. Right. Now, depending on the level of students, the kids in my struggling class, I'll have them use that tool right there. But if you're in a class where I'm emphasizing geometric constructions, well, guess what you're going to use? That. Okay. So GeoGebra naturally lets you differentiate as well within these apps. So I'm just going to save time and just do this, right? We know that any point on that perpendicular bisector is equidistant. And just before we go, just for the aha grand surprise here, let me delete that. I'm actually going to get a picture and show you quickly of one where I have the lows plotted. There it is. Put it back. And so let me zoom in a little bit here. Doesn't matter. That's actually, and I would give kids map of commercial real estate, of course, too. But if you look at this, check it out. Here's one Home Depot. Here's another Home Depot. What do you think? Was that, I mean, there was a lot of commercial real estate available in the late 80s and early 90s in this town where I grew up. But you know what? Why do you think they chose to build it right there? You know, they could have put it here or here, but that was intentional. And what's even crazier is that in my, I used to teach in Berlin right here. Berlin's right over here. Middletown, Connecticut's right there. And look at that. This Lowe's in Cromwell is literally right on the perpendicular bisector. So I tell teachers, you know what? You can go to sites like mapcustomizer.com, plot locations, analyzing things, drag the pictures in and do the geometry. Make it a performance-based assessment where you are the CEO of a company, given this person competition. Here's where go to Home Depot locator, get all the stores. Again, the possibilities with these apps are absolutely endless, literally.
Well, I love that, especially because I think it's so abstract and we stay in the abstract and like, why do I care about this? When am I ever going to use it? And I mean, I even felt like I had an aha moment watching you do that. So one of my key phrases obviously was UQ's math is about pattern finding, but then also use real data. We have this Google Maps and we have these things, the Lowe's information. It's pretty easy to just type in McDonald's and see where they pop up, how many Starbucks are there, and start making connections of why we would do this even with geometry. That's super powerful. And that makes learning sticky.
And fun, in my opinion.
And context enhances in student engagement.
Totally. And so even like taking that a step further, what are the top 3 touristy spots in New York City? Statue of Liberty, Empire State Building. I had students look it up and they found they want to set up their restaurant, whatever, to try to get. Turns out it's right in the middle of I-95 near East Hoboken, New Jersey. Good play, so, but you could drag the points around New York City. What if we did it Central Park instead and see, that'd be a better spot, right? Again, with 21st century tech, it's unbelievable, and hey, if you ever want to, I know I'm not personally doing webinars next week, but if you ever want to come back in a couple of weeks and do 3D, I'd love to show you that if you have time, but.
And we'll do 3D and then I'd love you to show me how it integrates with OneNote.
Absolutely. We can do that.
Awesome. Well, thanks for your time. Thanks, Chris, for moderating. And
thank you, Chris.
Recorded onto YouTube, so anyone can access it later. Thanks, you guys. Bye.
Have a great day, everybody.
Bye.
Stay safe. Bye.